Hi Gelato and SuperFluid community friends. Several months ago I wrote an article explaining how to use Gelato V1 to schedule our SuperFluid streams. Last October Gelato released the version 2. And today we're gonna see how we can leverage the Gelato V2 infrastructure to automate our SuperFluid streams. First, what is SuperFluid? SuperFluid is a protocol that allows us to stream money by second. It means that we can send tokens from one account to another account only with one transaction. The thing with the SuperFluid streams is that they are perpetual, and if we don't close the streams, they will last forever. And that's why Gelato comes very in handy, because help us to automate, to stop, for instance, the streams. And what is Gelato? Gelato is the Web3 decentralized backend which provides your smart contracts with enhanced features like automating a scheduling transaction or relaying gasless transaction. So let's go through our post. Well, one thing that we have to say is that the Gelato V2 has a modular approach. It means that it gives us much more flexibility how to configure our task. Remember that a task is a transaction that will happen in the future upon certain conditions. So let's refresh how to get with Gelato up and running. We need three steps. The first step is wire the Gelato infrastructure. It means we have to inherit the contracts that under the hood will allow us to communicate with Gelato. Second, we will have to decide which funding strategy are we going to use. Are we going to use the treasury and have one balance for all transactions, or are we going to pay for each transaction every time it runs? And third, we have to create the Gelato Custom Logic. It means we have to create the task, we have to define or configure the condition that will tell Gelato when it has to execute the transaction, and we will have to find the executable transaction. This is actually at the beginning, it can looks a little bit complicated, but it's actually quite easy once you have done once. Let's continue reading our blog. Then if we go now into the details, we can see that the first step was to wire the Gelato infrastructure. It means that we have to copy in our contract folder the opsready.sol contract and the types.sol contract. We can find these files in our repo. If you link here, you can easily copy the files and include in your contract. The second thing that we have to do in our contract is to inherit the opsready contract, and we will pass the ops address in the constructor. We can find the different contracts addresses in the Gelato documentation. We're gonna use in our demo later the address related to the Gelato Network. We have to decide, the second step was to decide what funding strategy are we going to use. We're gonna pay for each transaction. It means that our contract has to have a certain balance. We're gonna transfer the fees. We're gonna transfer some ETH by deployment. And then we have the Gelato Custom Logic. First, we need to create the task. If we have a look at how we create the task, this is the ops contract we were talking before, the one that actually we initialize in the opsready contract. And we need some exec address, which is the address where the contract should be executed, where the transaction should be executed, the executable data, the module data, and the ETH, the token that we're gonna use. The exec address is the address of our contract. The exec data is the encode vSelector data of our executable function. In this case, we will see it later, but is the close stream function. We pass the parameters, the sender and the receiver, and that's it. Then what is new in the version 2 is how we configure the task. And for that, we will gonna use the models. We have 4 types of model: the resolver model, the time model, the proxy model, and the single execution model. The resolver model is quite similar as we were used in the V1. It means that we create another contract. It can be the same, but it's a separate part of code that it checks with certain conditions. Normally they are not known up front. That's why we will require a dynamic check of the conditions. The second model is the time model, which is new, and is a model where it allows us to define when this task has to start and which interval has to be run again. The third model is the proxy model, which allows us to have a specific dedicated message sender to our task. And the fourth one is the single execution model, which is also new in this version 2. For our use case, as we want to stop a stream at a certain moment of time and only one time, we will use the time and the single execution model. Here we will see what is new in the version 2, and it's how we configure the module data. We will configure the module data by passing which modules are we using and which arguments do these modules need. In our case, we will have the module time and the module single execution. The module single execution, it does not require arguments because it's clear that it means that it's going to only run one time, and we have to pass the time arguments, which is the encode in uint 128 of the blocks time plus duration. It means the start of the task and the interval. In our case, we don't need the interval because the single execution will tell Gelato to only run once. Good. Then what is actually our executable function? Remember that we have authorized our smart contract to stop the stream. Then our close stream function takes a sender and receiver. Here we will pay Gelato for the transaction, and we will delete the flow using the CFA library that we have instantiated before. We're gonna see later how it looks like. Good, then let's see our contract. Our contract actually is quite easy. We have the instantiation of the SuperFluid host and the CFI library. We have some task ID in order that we can see later public task ID, the Gelato task. Then we initiate our contract passing the host and the super token. We're gonna use the fake dike in our demo, and we pass the Gelato ops address relevant for our network. Then we instantiate the ops ready, and we do some other instantiation. Then here we see the task that we were talking before, the create close stream task, which take the arguments of the time arguments, the modules, builds the data that we're gonna execute, which is encoding with selector the close stream function, passing the arguments of the sender and the receiver, and this is the close stream function that is gonna be called by the only ops. It's going to be called by the ops contract. Therefore, we have the only ops modifier, and actually that's it. Well, we have a receive and a withdraw function to allow to send ETH to the contract. So far, so good. Then, so now let's go. We're gonna do the demo. We're gonna go to our repo, and we follow along the different steps. First, we have to clone this repo. I have already cloned the repo, and the repo is here. We have to join install. I've already done that. I don't want to make you wait. Then we're gonna compile. I'm gonna open a terminal. Now we're gonna compile our contracts. Right, they compile perfect. I'm gonna open a second network, a second terminal, and we're gonna fork girly in our local hard hat. Jan fork. You can see the different commands in our package JSON. Sorry, before we can do the fork, you have to copy your you have to update the env template file with your private key, your infra ID key, and in the case that you want to verify your contract with the Etherscan APK, and then change the name to the .env file. I've already done that. I have the private key, I have my infra ID. If you prefer to use Alchemy or Moralis or whatever JSON RPC provider you want, then simply you have to go to the hard hat config and change the hard hat URL and the girly URL for later. Then I've already done that. Then we're gonna spin our perfect. We want to spin our fourth girly on local, and now let's see what is telling us. Fine, we have only to deploy our contracts to the local host. Okay, deploy to localhost. Perfect, it's deployed, and we see here that we have our contract deployed. Good, then we receive something like this. Yeah, correct. Then it also tells us that we have to copy the address. In this case, it's the same as we have seen. We have to copy this address into the helper file. Well, in this case, we're gonna put it here. Perfect. We have already the address copied. Actually, we do that to afterwards don't have to copy every time. We export the address of the contract and we will use for other scripts. Good, then now start actually the fancy thing. We're gonna run Starstream localhost. Let's have a look at Starstream. Our Starstream is in the script folders. And actually what we do here is we instantiate SuperFluid SDK. We instantiate the SuperFluid SDK with the create framework. And once we have our framework created, we simply create the flow with the super token we have with a certain flow rate, which is 100 tokens per month. Remember that we have to give the flow rate per second and to the receiver. The receiver in this case is also here, is the second, well, it's one of the addresses of the local network. Then that's it. Then now we're gonna copy, we have already copied, we're gonna go to the terminal and we're gonna run stream localhost. Hopefully it works good. Excellent. We have the flow. We have a flow rate of 100 per month, and this is creating the stream. It means that it's already running. We have already our stream working. Then what is the next step? The next step is to authorize our contract to run. If we look at the authorized control, once again, we instantiate the SuperFluid framework, and then we say that we want to update the flow operator permissions, and here we say that we want to give the closest stream address, which is the address of our contract. Then if we do that, it will, perfect, it works. We have given our contract the authorization to stop the stream. Then what is the next step? The next step is to create the task. And remember, we're gonna do that with our contract. Then if we head to our script, we will see that we are instantiating the closed stream factory, connecting to the address of the contract, and then simply we're saying that we want to create a closed stream task to the receiver in 300 seconds. Let's do that. Perfect. The stream is still working, and we have already our task created. Now we have to it tells us that we have to copy the actually number of the block timestamp when it was created, when the task should run. Normally, when we are on Goerli, we don't have to do that. But as we're going to impersonate the executor account and launch our transactions ourselves, we need exactly the same start time, because if not, we won't find the task. Then if we go now to the stop stream, we have to copy exactly here these values. We will now look what is exactly here. Okay. Then if we follow along, then now we can stop the stream. The stop the stream script is this one. And actually, first what we are doing is we are impersonating the Gelato executor account, which we have the address here for Goerli, is this one. Then once we connect to the ops contract of Gelato, the one that it's already then we connect to the ops contract with the executor. We do the exact same steps of defining the task as we did in Solidity, but here in TypeScript. We pass the start with a new number, and then we connect to the ops and we execute the transaction with the address of the contract, the address of the resolver, which is the same, the task creator, the executable, and all of the information that is required. What we do here is that we're going to advance our blockchain to the time when this task should run. If we comment this one and we try to execute the, sorry, we're gonna copy again. Now, if we want to stop our stream, but we haven't advanced our blockchain to the time when it can be stopped, then it won't run. We will have an error. And if we look at the error here at the ops, time model too early. It means that Gelato is telling us you cannot run this task because it's not yet time. Then we will do the same again. We'll stop the stream, and now hopefully our transactions is gonna go through and it's going to stop the stream. Good. It works perfectly. Here we have run our project in a local for Goerli hard hat node, and now we're gonna see how we do that in Goerli. Now we're going to do a deployment to Goerli. Then we don't need the hard hat node, and then we gonna simply deploy to Goerli. Hopefully it works. Okay, stream deployed successfully at this contract. Good. Remember that we have to copy, as we did before for later usage, the closed stream here. Good. And now we're gonna verify our contract. Good. We're gonna verify our contract. Let's see if it verifies. Should work. We wait some seconds for verifying. Excellent. We have already our contract verified. Here is the contract. We have the read methods, the write methods. Excellent. Sorry, then now we go to we could go to start stream, of course. We could do that. But I think now we're gonna go to the SuperFluid app and we will demo how to start the stream from the SuperFluid dashboard. Here is it. We go to the dashboard. We're gonna go to Girly, testnet Girly. We're gonna connect our wallet. Great, we have the same user as I already passed the private key for our contract. And I'm gonna take another user. I'm gonna take this one. Okay, no. I'm gonna take this one. Good, we are in this one. And we're gonna start a stream. We're gonna start a stream to the address I just copied, this one. We're gonna select the super token and 100 tokens per month. Okay, we're gonna start the stream. We confirm. Go to token page, and in some seconds we're gonna see how we start streaming the token. Now remember that our next step is to authorize the contract, because the contract is going to stop the stream. Then let's go here. We have already copied the contract address, then yarn authorize Girly. And it will give, yes, sorry. As we are now on Girly, we have to go to authorize, and in order to instantiate our framework, we have to pass the Girly address. Now it's going hopefully to work perfect. It's going to authorize the flow to the contract. Let's see if it works perfect. Authorization successful. Wonderful. Then let's have a look. Now we have to create the task, the stop stream, the stop stream task. Let's see if what good we have already. We can see it here. Our stream working to stream sending tokens to this address. Then now let's go to our contract, the closed stream contract. And we're gonna work, as we have verified the contract, we can work here. Then we're gonna connect with our MetaMask. Perfect. We're gonna copy this address here. And now let's create the closed stream task. We're gonna create, this is the receiver, and we're gonna pass 300 seconds. It means in 5 minutes it should stop. Good, let's create the task. We could do it with the script too, but I prefer that we see it here live. Okay, we will wait for the transaction to be success, perfect. Then we have created the transaction. I have a public, we will have to refresh. I have a public, exactly, we have a public variable with the task ID. Now, if we go, in order to see the status of our task, now, in order to see the status of our task, we're gonna take this URL. This is a beta URL. Normally you could use the normal app.gelato network URL, but as this task is still, it has not yet run, we're gonna see it in this URL. Then I'm gonna paste it here. Great, and we're gonna take our closed stream task and copy it. What is this? here, sorry. We're gonna pass here our task ID. And normally, exactly, this is our task. We can see that we have our clustering function. This is the address of our contract, and it should run in 5 minutes was the interval. And let's see what time is it right now. Is 3, then we have 2 more minutes to go. If we go to see the logs, we see that it's checking and it's saying, hey, the still is, we are waiting for 1 minute 38 seconds. Then let's wait. Good, it's about 4 seconds to go. Good. It's see that it's too early. Pending. This is good. It means that our transaction is waiting for confirmation, but it's actually already executed. If we go to our executions, we should see that is still, do we have none? Then it will refresh in a minute, because actually the execution has been not yet. Okay, we wait for the execution, we wait for confirmation. Sorry for that. Waiting for confirmation. Okay, we have already 1 execution. We can see here the execution has happened. And now if we go to our SuperFluid dashboard, perfect, our stream has stopped. Then that was it. We have the repo with the demo code. We have our article explaining every step of the process. We don't have a conclusion. I would say that it's really worth trying to understand how Gelato and SuperFluid works to decide which method, whether using the SDK or using the contract to use. It's actually is quite nice to see that some transactions happen when you plan that they happen into the blockchain. And stay tuned, because the next month we're gonna write an article, we're gonna write another blog answering our good friend Franz, who is asking something and so far no one has answered, and we want to demo how to do that with the off-chain resolver, a new feature that Gelato will release in the coming weeks. Then thank you very much. Hopefully you have a beautiful evening tonight and you enjoy passing to 2023. Happy New Year and Guten Rutsch. Feliz año. See you soon. Bye.